Okay, so the next thing we're going to look at is we're kind of moving away from PHP a little, or really expanding PHP. Well, I guess the best way to say it might be we're going to bring another language into PHP. We're going to work with two languages at once, not the old saying, two is better than one, right? So we're going to work at two languages at once so that we have more capabilities with what we do. In particular for data stuff. We've seen writing files, text files, basically, where all our data is stored in a text file in the same order. And it's great if we need all the data in the same order. But a lot of times we don't need all of the data in this, or we don't need it in the same order every time. In which case, after we read it from a text file, we have to do a lot of parsing and stuff. So a better option for data storage, if we don't need all of it every time, is to use a relational database or use some sort of database. We're going to use a relational one. In particular, we're going to look at Mysql. So first off, just a review on Mysql. I'll put a little subheader here, no PHP yet. We probably won't get to intermingling them until Thursday. I could probably talk really fast and get to it, but I'm sure that wouldn't do much but overwhelm you. So we'll review Mysql today, and then we'll intermingle it with our PHP on Thursday. So let's start with a couple definitions. Database. So a database, the technical definition is a structured set of data held on a computer especially one that is accessible in various ways. Kind of a mouthful. I was looking very carefully at my notes. Obviously, that's copied right from the dictionary. And that word especially is going to mean something, have a lot of meaning. I'm going to put TD here instead of a star. So that's our technical definition, what we read in the dictionary. The more useful definition, the daily language sort of usage thing, is just a place to store data. So that's our first term to define here. I guess I didn't really need to underline especially. At some point in your life, you may have encountered the word especially show up in the dictionary before. And that means that there's the usage of the word doesn't exactly match the definitions. So we'll see that in a moment. The other term is data structure. And our technical definition on this is data organization and management format, I'll write down here, format that enables efficient access and modification. And modification. So technical definition there. The little asterisk one, the more useful definition, is just a way to handle data in our RAM and CPU. But data structure, it's an organization and management format that allows us to efficiently access and modify our data. So that's the key points here. Between the two words, the database is in storage, and the data structure will be in memory and the CPU. So obviously we're going to need to bring those together, right? We want to keep our data around, so it's over in storage, probably a solid state drive anymore. Some people might still have disk drives. But when we go to work with it, we need it in the CPU and memory, the processing area. And that's where a data structure is. So loosely fitting these definitions are some things we've definitely seen before. A user's random file structure on their machine, right? Everybody that uses a computer probably has a slightly different file structure set up in their documents folder or on their desktop, the way they organize all their files. Technically, that fits this definition, right? It's stored on a computer, accessible in various ways. On some people's machines, it might seem a little odd to call it structured, but it kind of still is, because they know where to find their stuff. So technically, that's a database. I guess technically a file structure would be a hierarchical database, but we'd never call it that. That's just a technical thing. That's where the especially comes in. Because if we're referring to, well, a file structure is a hierarchy database, we represent it as schematic with a hierarchy chart, right? A bunch of folders and subfolders, and eventually get down to files. So a hierarchical database. But even if you were talking to people that knew that technicality, if you called it that, they would just look at you like you're weird and be like, well, why would you say that? So we'd never call it that. When we say database, we mean something a lot more structured. So that's where the especially in the definition comes from. Or putting things in variables, for an example of data structure we've seen before. Putting things in variable is a way to access and modify our data. We wouldn't really call that a data structure though, because, well, just like the thing with the files, we're typically referring to something more organized. A file structure, the hierarchical database, would fall apart calling it a database because we all set up our own file structures on our computers. And other people might not know that file structure. They'd have to look around at the very least and figure it out. Same thing if we used all variables. It allows us access and modification, but us, as in the person that wrote it, somebody else is going to take a minute to figure that out, right? So it's not really, those things, while they fit the definitions, are a little bit loose for what we actually want to mean when we say database or data structure. What's really different about how we use these words is the organization. It's when we say database, we're probably referring to a relational database, like the big header I had up here, the most popular one, Mysql. It's a highly organized thing that has been around since the 70s. I believe it was pretty much set in place by the 70s. So it hasn't, lots of people know how to use that. You don't have to learn your organization structure to use that. So yeah, we're really referring to a relational database. And data structure, I guess I put it on the next page. I mentioned variables fit that definition, but arrays fit that definition a lot better, right? Because arrays, we organize and manage them all as a collection. We have lots of different data points that are organized together that we can move that whole array at once, loop through it, refer to any particular thing as an index. So it's, an array is our most basic data structure. There are some better ones. If time allows, in weeks 7 and 8, when we get to odds and ends at the end of the semester after we've covered all those core, all the key concepts, the main concepts, we'll look at some other data structures, things that are better than arrays. But an array fits that definition a lot better than a variable. So usually we're referring to things like that, more organized things. And well, for our purposes with the PHP, what we're getting into probably later this week, we're going to be using relational databases and arrays. That's why I brought those up. So when we say database, and I'm going to put it in quotes this time, we're usually referring to a relational database. And that is, everything is kind of related to each other. So hopefully these colors will show up. So like the first one, each data point is in a field. Each data point in its own field. So I'm going to draw a picture 1, 2, 3, 4. Hopefully I have room down here. So each data point gets its own little box, its own little case. Every data point is separate from every other data point, and we call that a field. Then related fields link into records. And I went back and forth on words a few times, not hyperlink, not the hyperlinks like we're used to using in HTML, just a connection. And I went back and forth on words, and link, like links in a chain. And that's what I mean there. It connects up into records, builds up into records. So we'll have several data fields that make up a row in a table, but our technical term for that's going to be a record. Another color. Then related records link together as tables. Link into tables. Hopefully these colors are showing up. This is more how I would always write up at the school, in the classrooms there on the whiteboards, when I have lots and lots of markers and lots of colors. This color coding can be useful. So lots of records, then we can build up into a large table of data. And I need one more color, which I think if I write really hard with the red, it'll show up as well from trying it earlier in the video. So then our fourth point is related tables are linked by common fields. So then somewhere over here, we have another table. Yeah, I'll do it this way. We have another table set up with lots of rows and columns, or fields and records. And somewhere in there, we have this matching field, like maybe an email address, which is really nice on web pages. In your DBMS 110 class, sometimes that unique field might have been tricky to get to, but web pages, it's real. One thing we know is anybody on the web probably has an email address, and by the nature of email addresses, they have to be unique. So on web stuff, we can always just use a email for a unique ID, and we know that's in particular to a human, or a name field, maybe a city field, but some sort of connection between those two fields that I marked in green there. If the color will show up. And that's where the relational part comes in. Every data point is individual. We have all these individual cells on this table, all the individual cells on this table, but the related cells build up into records, and the related records build up into tables, and the related tables connect to each other by common fields. So we have this big circular picture of all these relationships, a highly organized format, so the computer can pinpoint any single data cell on there. It can grab them all, or it can just jump to a particular one, that one or that one, and get right to that data. So then, unlike our file structure, we don't need all the data. We don't have to breathe in everything in both of these tables. We can just jump right to a particular cell and read in that cell. Quickly. It's very, a computer can do it very, very quickly because it can follow these relationships together, follow the links in the relationships, and follow the connections, not necessarily process every bit of data there. So it allows us to ask for any size collection of these data points. Ask for or filter any collection. We can ask for a single cell. We can ask for all of them. We can ask for anything in between. We can take half of this row and half of this row and mix them and put them together with no problem. And take the other half of this row and this column and mix them together. So any combination of our cells we can get very, very quickly. And when we ask for it, that's called a query. That's what the Q stands for. It's often done with some form of structured query language. The SQL, I guess it's already wrote on the board. I kind of ran out of room. Structured query language, which we pronounce SQL. We'll go ahead and add add in the missing vowels so that we can say that word, because it's one that shows up a lot. And something that gets a lot of people at first about SQL, especially if you just had the quick introduction class, the 8-week class. I think most of y'all took that the first 8 weeks, right? The DBMS 110. So when that's all you, people have had, one thing they don't realize at first is this is not a single language. SQL is an entire category of languages. So the one we're going to look at here might be slightly different than the one you saw before, because SQL is a category of languages, not one particular language. So some words might be slightly different than what you learned before. Yeah, so then the next bit of notes is about data structures, which we'll see when we get to, that's when we get over to RAM and CPU, the processing. We'll take stuff from the database and send it to a data structure in order to work with it. So if we put it all in variables, that would be a mess. So we'll bring it back as an array. So like if we ask for this row of data, when we get that back, we'll get it as an associative array. And then each of our column names will be the indexes for that associative array. We'll see that when we get to the PHP part. And if time allows, in week 7 or 8, when we get to just the odds and ends, after we've covered all the core things, we'll look at some other data structures that can be quicker than arrays to work with if you want to get more speed, but speed's not an issue like it used to be. That's for sure. So for storage, we need a relational database, and then we'll bring that. For processing, we'll load the query results into a PHP associative array and then work with them that way. So there's only a couple queries we need, really, we'll use a lot. So we're going to look at four of them. I'm going to go ahead and review those. And there's also MySQL is a category of things, just like SQL language I was referring to. So there's lots of MySQL. So when we got set up for the class, I'm going to share my screen. I recommended that you install Jam. It's just a test environment for you to use, so that'll there are other test environments you can use as well. Let's look at that button. It doesn't seem to be open. There it goes. So we installed a MySQL. That opened twice. We installed a MySQL, and in particular, we installed MariaDB. So whenever if you're working on your homework and need to look something up, make sure you look it up in MariaDB. That's the flavor of MySQL we have on Jam. And if you're using domain hosting, most of your free domain hosts will also use MariaDB because that's what WordPress uses. And WordPress is by far the most popular, so any free hosting site has to match what WordPress does pretty much by default. And then we ask for something different if we want to do something different than what WordPress does. So you'll probably be using MariaDB. And I made a supplemental video walking through setting up MariaDB with the software that we'll be using. It's called PHPMyAdmin. However, as we get started here, PHPMyAdmin is an interface, a graphical user interface that gives us full control over the database, which means it's also there's a lot going on. So to quickly review the SQL, in particular the parts that we're going to need to put into our code, I was going to look at it the other way. So really, we're going to review it twice here. Once in the command prompt where we're only looking at the language, and then we'll come back and look at that interface because the PHP MyAdmin can be a bit overwhelming. There's a lot going on. So I'm going to start by just looking at the language. I'll keep the control panel open for now. So if you go to your File Explorer and navigate to where XAMPP is installed, in the XAMPP folder, there's the htdocs folder where we put our web pages to test them, run them from the server instead of run them through a virtual server instead of just opening them locally. We've been doing that all semester. But a couple of folders down from that, you'll see a folder called MySQL. In that MySQL folder, there's a whole bunch of things. So this is the language that we're using, all the files for that language, and more folders. Inside that MySQL folder, there's a folder called bin. And in that bin is a whole bunch of executable files, a whole bunch of applications. They'll be listed as applications, but a whole bunch of executable files. And you can probably notice here on my screen, a whole lot of them, actually the majority of them, have MySQL in the name. So that's what builds up the language. That's the stuff building up the language. But there's one in particular, this one here, is just MySQL. It doesn't have any extra stuff. That's our core interface for accessing. So I'm going to pull it up from that core kernel interface up in command prompt. You can go however you would normally open command prompt. You can open it and navigate to this folder, or the quick way is if you're in File Explorer, if you click in the white space where you'd like highlight the address to copy that file directory, if you just click there and type CMD, it'll open the command prompt right in that spot. That's probably the quickest way to get there. And then to access MySQL on here, well, we just type in the command MySQL to access that. But we need a little bit more information. MySQL is a server thing, because databases often get huge, and we often run a lot of processing power when we query them. So databases usually tend to run on servers. So we need to say where MySQL is located at. Or when we say MySQL, we're just asking it to open the interface. And then we have to say where the actual database is connected. So -H is the command to enter the host, and the host is going to be localhost. And then we have to say what user we are and what password. If you have not changed it, the default user is called root, and the password is an empty string. If you change that, I assume you know what you changed it to. And if you change the password, it's -P to enter the password. But if you've left it at the default, there's an empty string for a password. We don't have to type that one in. So open the MySQL interface. The host is a local host, and the user is just root. When we hit enter, you can see the command prompt change, and now we're looking at MariaDB, which is another good way to tell what version of MySQL you're on. You can find that where you have it installed and just open it and check the command prompt to see which version of MySQL you're using. So for us, it's going to be MariaDB. And if you have to look anything up, make sure you put in MariaDB instead of just MySQL. There are some slight variances. I'll try to point out a couple, but we only need to do a handful of things in order to access the database and bring the data to and from our website. So first off, I'm going to type in some commands that should look familiar from your last class. We'll put show databases. we see all the databases we have available. Probably want to create one, right? So this is one, this command we might need. A lot of domain hosting sites, both free and paid for ones, they don't like you to actually create a database. You tell them you need a database and they'll create one for you and give you the name of it. So this, but others, we will have to do this. So we need to create a particular database to work with. I'm just going to call it testDB. And then semicolon to end the instruction. We've seen stuff like that a few times. So we're going to create a database to work in. And the first thing I want to point out, I'm actually going to point out a few times today and then again Thursday, is I call that show databases command again. Oh, and I kind of follow this convention. It's SQL is not case sensitive, but it is fairly common to type all of your SQL commands in all caps, and then all the stuff that you give names to make it Pascal and camel case, which I use Pascal case for the table here. A capital letter to start with, all the words just jammed together, then each subsequent word starts with capital letter. That's Pascal case. If the very first letter is lowercase, that's camel case. So typically we do camel case for our stuff and all caps for the SQL commands, just to make it easier to tell at a glance what's the language and what's our stuff. But I type that in Pascal case, but if I ask SQL to show it to me, it shows it to me in all lowercase letters. So this is going to be a big issue as we move this, as we connect SQL to PHP, and that is SQL is not case sensitive, but PHP is case sensitive. Y'all have probably seen that at least once by now. Have a upper or lowercase letter in the wrong spot, have the case reversed on a letter in one of your variable names, and PHP can't find it. And that happens when we bring stuff back too. So this was created in camel case, and anytime we ask, or it was created in Pascal case, sorry. And anytime we ask SQL for it, it's going to tell us that name in all lowercase. But if we ask for it from PHP, we have to write Pascal case like we originally typed it. So I will make sure I'm going to remind you, put that reminder in several times this week, that SQL is not case sensitive, but PHP is. So in PHP, it has to be the way you created it. So now that we have that database, we can use it. So let's use testDB. You see the prompt changed to say what database we're in. And there's a much nicer interface. We're going to look at the interface soon, but the interface has a lot going on. So I wanted to review the language here first, the 4 parts we'll need, and then we'll look at it in the interface that has all kinds of other nice little buttons to click on and much more organized than a command prompt. But I was thinking that would be overwhelming. Then we'll review the language again there. That way we'll see the 4 things a couple times, make sure it's fresh on everybody's mind in case it's been a minute since you've had this. So we have a database, but there's nothing in it. So the first thing we have to do, and this is the one that even if the domain host won't let you create a database, you will definitely create a lot of tables. So our keywords create, and we want to create a table, and we need to give it a name. I'm going to call this people. My standard example in classes for data stuff is a name, age, and town. And actually I have a second table here to go over the relational stuff in mind, but we'll see that in a moment. So we're going to create a table called people, and we need a couple fields for it. So the first field is in our database, we actually want to make sure every single one of these rows, our records, has a unique identifier. And when we get to actually doing web stuff, an email makes a great unique identifier. we know we'll have that. Or it can be good form. Emails are unique, but we want to make sure there's something unique. So it's good form to just go ahead and throw a number on there. Also, when we get to the interface, some buttons will be turned on if there's not a unique primary key for every field. And assuming everybody remembers hearing that word before in your DBMS 110 class. So we want to make sure there's a primary key. So just for good form, I usually throw one in there. I'll give it the name of the table, ID. So in this case, people ID. And I just want a number, an integer, a primary key. And that bunch looks the same no matter what flavor of SQL we're using. But I don't want to type that number in every time. A computer can keep track of just a number that's there that I'll probably never use, but just to be certain that there's a unique identifier for every row. So I'm just going to use auto increment. And this is one of the words to look for to tell what flavor of SQL you're in. I know in the past, a lot of people have used the Oracle version, Oracle MySQL. And in that case, auto increment is just jammed together as one word. In MariaDB, auto increment has an underscore. And other versions of MySQL, auto increment might be abbreviated. So we want auto increment with an underscore, auto underscore increment. That might be slightly different than what you saw in your previous class. But that's one word. Also, that's one word I look for a database or in a database if I don't know exactly what database I'm in. If I know it's MySQL, but I don't know which MySQL, I always look for auto increment as the first word I look for to try and figure out which one I'm in. And that's just a technicality, just to make sure every row can be uniquely identified. Let's go ahead and throw that in there and let the computer count it. It's just storing a small integer. If your database gets huge, right? If you've got millions and millions and millions of records, then you might not want to just throw a random number in there because that's going to add up to a lot of millions and millions and millions of random numbers adds up to a lot of space wasted. But for our purposes, just throw a random number in there, and that way you can be certain that you get all the functionality that you need. The rest of these, we just need some fields to put data in. So my standard example is a name, age, and town. That's what I use in classes. So a name, but just like we saw in the ID, after we give the field a name, this is our column header. We want to say what type of data it is. So I'm going to make this a string. We can put text. Text is 255 characters, and always 255 characters. We probably don't need 255 characters for a name, right? It's usually a lot shorter. So a related type is a variable number of characters. Varchar, because most people just go ahead and read that. It's variable characters. So it's only going to take up as much space as we need. It's going to vary in size. And then we just put in a max size. And we can go all the way up to 255. We can get as much as a text field, but usually we use that because we don't need as much as a text field. So I'm going to say 32. I think 32 characters would probably be enough to type most people's names. And if there's more than 32 characters in the name, they are probably quite used to their name being truncated anyway. So a name, I'll type an age. And age, we always give those as integers. It's pretty common in computer stuff to abbreviate that. And a town, which again is a string, I'm just going to put varchar with 32 characters again. Almost had enough room in that line. So a name and a town, those are strings. An age is an integer. We don't need any other special instructions because we're going to put data in those fields. And then some unique identifier for the records, each record that we load in. And then SQL wants a semicolon at the end. And I'm going to keep reminding you about the semicolons because when we get to PHP on Thursday, we're going to pass SQL stuff in as a string. And PHP also wants a semicolon. So that means when we do this in PHP, we have to put a semicolon inside the string for the SQL and outside the string for the PHP to end the line into the PHP. So I'm going to keep reminding you about that. Okay, so it created that table. And we can put some data in there. That's another thing we're going to do a lot of, is we're going to insert data. It's a common thing. We'll have a form that looks nice on a web page and boxes for the user to type in, enter numbers, or like our order form, we have those colors and sliders and radio buttons and checkboxes. But we're going to take that stuff from the form and insert it into a database. So that's our keywords to start with. We're going to insert into, and then the table we want to insert stuff to. So insert into people, and then what fields do we want to insert stuff to? So this first, the ID here first, well, that's auto increment. The computer is going to handle that. So we don't need to insert anything into that ID. So we're going to insert a name, an age, and a town. So here we just need the data we're going to insert. And then what values are we going to insert? That's our next word. Values, and then we'll pass the stuff in. So name is a string. And just like we see other places in programming, if it's a string, we need it in quote marks. Double quote or single quote are interchangeable in SQL, whichever one you want to use. I'll just make up some names to put in here. So Sally is maybe 32 years old and lives in Salem. And we get a little message saying that it put it in there. I'm gonna put a couple more. So here in the command prompt, you can just hit up to get the last command, and then I'll change the data out here. So Sally, what's another name? Bob is maybe 41 and lives in New Albany. Put it in there. I'll push up. That way I don't have to type all of that again. Yeah, that one is kind of a lot to type. Keywords insert into, the table we want to insert stuff into, the fields we're going to pass things into, and then the values we're going to insert, and they have to be in the same name as what we said the fields they're coming in. So what's another name? Maybe Becky, like 19 years old and lives in Sellersburg. There's 3, I'll do one more. So for a fourth one, maybe there's a David who's 23 years old and lives in Clarksville. So we got a bunch of data inserted into our table. We created the table and insert data. That's the first two we're going to do a lot of. There's 4 that we're going to do a lot of. So first 2, create table, insert data. And we need to get that data. So you might remember this from your database class. We have select queries where we're asking for data. And what do we want to select? I'll start with a wildcard selector. Select all or select everything. This is just a wildcard. So anything we have that could be put in there, just go ahead and select that from people. And if you want to, there's conditions, we'll see them in a moment, where 1, as in 1 meaning true. 1 is true, 0 false. So a basic Boolean, not the number 1, the binary on off, so true. So select everything from people where true. It's basically just saying we want everything on that table. And we can narrow that down, but that gives us a table of data in this form. Every data point is in its own field, and all related fields are linked together as rows, or we call them records. And then related records, like all of these records, have a person's name, their age, and the town they live in. So those are all related. So those link together into a table. The related data about people. So all the relationship points is why we call this a relational database. And we can narrow down our selection. We don't have to select all of it. So maybe we select just a field. We select just the name field from people, because we don't have a second table yet. Select name from people where age is bigger than 30. So we only want to know what people do we have data about that are older than 30, and narrow it down that way. So you can see the relationships. And does all this look familiar to everybody? I think for a lot of y'all, it hasn't been that long since you had the class. So hopefully it's fresh in your mind. And we will see a much nicer interface soon. I decided to review it here so we can look at just the statements, because the interface has a lot going on. I was thinking that would be overwhelming. I wanted to look at the language first, because this is what we're going to need when we actually get over to the PHP. The interface just makes a lot of things easier for us. So that gives us a table in that format. Each point of data gets its own cell, and related data links together into a row. So fields link together into records, and then related records link together to build up a table. And then, like I drew in the picture, we can also connect that to other tables of related data. So make a second table here so we can do all the connection stuff. So again, our keyword is create. Yeah, there's one more. I said there was 4 we're going to need. We'll do the last one in a moment. So that's 3 of them. We'll create tables, insert data into it, and select stuff. And then there's a 4th one that we'll use a lot coming up here in just a moment. But for now, let's create another table and look at do a little expansion on the select queries. So we'll create a table. I'm going to call it taste. And again, I want to make sure that I have full functionality from this database table. So I need to make sure there's a unique ID. So for example, here, I'm going to put taste ID. And again, I'll just have the computer keep track of an integer, give each one a number, just count them. So an integer be the primary key, and set it to auto increment. And that way I know that everything has a unique ID and I get the full functionality out of the database, even if I'm never going to use that number in any code that I write. Then what else do we need? We need a way to tie it together. In this case, I was very careful to make sure all the names were unique, so I can use that as a foreign key. There's unique names here. And when we get to web stuff, we know emails are going to be unique, so that always gives us a unique foreign key. For this example, I'm just going to use name, because I was very careful to keep those all different. And it needs to match. When we created it, name was just a variable number of characters, a string with up to 32 characters. Varchar with 32, and just some different data than their age and where they live. I'm going to put in favorite food. I guess I'll abbreviate it. So that's enough for a second data table. And run that query. Whoops. Oh, favorite food has to have a type. That's just going to be a string, right? We'll just enter a string, and most foods we can probably get in under 32 characters. That's a long name for food. So we have a second table where we need to insert data in. So again, that's the first of the big four is create a table. The second one, insert data. So insert into our taste table, just names and save food columns this time. We need some values pulled off our other table. So maybe like Becky likes pizza, and I'll hit up so that all I have to change is just the up arrow to pull up the last command if you're hearing command prompt. This can be a good place to practice just the SQL and keep all the other clutter on an interface that has buttons for everything a database can do out of the way, because that interface looks very overwhelming when it has everything a database can do. What's another name we had on there? Bob was on there. Maybe Bob likes hot wings. And obviously, I'm just making this data up as I go along. I'll hit up again to get another one. Becky and Bob. There was a David on there. Maybe David likes lobster. And the last one was Sally. So scroll up to get that insert query again, and let's say Sally. Sally likes cheeseburgers, the all-American food. Then we can select all that data and see what that looks like. So that's create tables, insert data into it, then select stuff from it. So if we select all from taste, and that where true clause at the end, that's what it is by default. So we don't actually have to type where true every time. So I'm just going to put select all from taste and get the whole table. And might as well pull the other one up here to, we got it, select all from people. That way they're both on the screen next to each other. So there's our data. Every data point in its own field, fields connected into fields connect to related data in records. Related records connect into a table, and tables are related by common fields. So there's relationships all over the place. We can single any particular piece of data out. So like select everything from people where name equals Becky. And pull up just Becky's information. Or select age from people where name equals Becky. Or pull up just that one piece of data about her. And very, very quickly, right? Notice that it shows 0 for the time. It happened so quickly. But we can also expand it. We don't have to stick to just that one table. We can join our tables together. So I'm going to select that in a more complicated way. So maybe I want the age, people's age, somebody's age and their favorite food. And we have their age on the people table and their favorite food on the taste table. So we can query them together. And do that, we put the table name dot the field we want. So people.age, we want people.age and taste dot save food. From, and then from is what table are we looking at? Well, that's on both tables. So we have another keyword, people table, join that with the taste table. So we're going to put both tables together, connect them together, and pull up all that data. And yeah, I'll run this without a condition. Because if I run this like it is now, something looks a little off about that data, right? We got all the ages next to pizza. We got all the ages again next to hot wings. But there wasn't duplicates on that favorite food. And that's because we just asked for all that data. We didn't narrow it down at all. So we want to make, whenever we do stuff, we usually want to narrow it down some. We don't want to just ask for all the data. So if we're asking for all the data, we might as well be using the file. So yeah, I'll put that query in again. So select table name dot field name. So like people dot age or taste table dot save food column field, whichever word makes the most sense for you to think about it. Field is the technical term, but it's a table, so columns and rows often make more sense in our minds when we're thinking about it. We're going to select those two things from the people table joined together with the taste table, where people.name is equal to taste.name. So make sure I don't have any typos in there. So a more complicated query, to be perfectly honest, a lot of times if I'm sending this to PHP, I'll just do a select all query on both tables and then throw what I need in variables and use if else on the other side. I find that a lot easier, but this can be quicker. This is definitely quicker. And that only works on small data sets. If I know it's going to pass maybe 100 rows, past 100 rows, I don't do that. I do it in the SQL.
Question: do you need a single equal or a double equal?
Single will work here.
Okay.
Oh, that is different than Oracle, isn't it?
I don't remember. I'm just so used to screwing up and putting a single when I need a double or triple that I had to ask.
Okay, in MariaDB, a single is enough. I think some flavors of MySQL might want a double equal sign. That's another one you can look at to tell what flavor of MySQL you're in. But yeah, a single one works here. Let's see if a double one throws an error. That way it's less confusing. Oops. I'll put in a double equal sign. Oh, it doesn't even like the double equal sign. So single equal sign here. Yeah, and it's near equals test.name. There we go. That way we've got stuff coming from both things. And pull that up again to look at it. So that's probably the most complicated thing type of select query you'll want to run in order to get the data to the script. And if it's a short data like these tables, I would just grab it all and put it in variables and then use if else in the script. But if you have large data sets, which data sets can get very large very quickly, it's better to narrow it down in the SQL first. I usually go up to about 100 rows. If it's less than 100 rows, I'll do it with an if else. If the tables have more than 100 rows, I definitely want to narrow it down in the SQL to save time. And when we get up in the millions, yeah, definitely even do more complicated SQL than this. Anything you can to cut down the time. But that's probably the higher end of that. So that's 3 of the 4, right? I said there was 4 things we're going to need. So we're going to, when we're working with it with scripts, especially on websites, it's these four. We create tables. You might have to create the database. Create tables, insert data into those tables, select data from those tables, and update data on those tables. That's the last of the big four we'll need. So let me pull up all the data from the people table. Select all from people. So we have this data. Maybe Sally had a birthday. We give ages as integers. We don't say Sally's 32.99 years old. We say she's 32 all the way up until her birthday. So maybe Sally had a birthday. So the other query we're going to want to run a lot with our scripts is an update query. So we're going to update the people table, update table name, and then our keyword set for what we're changing. And if she had a birthday, we're going to set age equal to 33. I'm just going to type it in. We might not actually know that. So in more complicated situations than just a quick SQL review, we'd probably want to do a select query to find out what her age is, add one more to that age, and then update it to that value. For review, I'm just going to update the people table, set age equal to 33, where name is Sally. And said that works. So if I select all from people, yeah, you can see her age updated. So that's the four we need. Create tables, insert data, update data, and select queries. Probably don't want to do that in command prompt, right? I decided to start here because the interface can be well, we're getting ready to look at an interface that has full control of a database. It has buttons for everything that can be done on the database, which is a lot of buttons. So I was thinking that would be overwhelming, so I wanted to review the SQL here first. Does anybody have any questions about that quick review before we look over at PHP My Admin software? Okay, so I'm going to close out of that. So it's in the XAMPP folder. The MySQL folder has a folder called bin. If you want to go from the command prompt, or you can just double click on this. It's an application. If you double click, you get right in there. You don't have to put the login information. That only works if you're on the machine, though. So on the XAMPP one, it'll work on your thing. But we probably don't want to work in the command prompt, right? It's not 1982. Command prompts seem prehistoric, outdated. We want buttons to click on. So in the XAMPP control panel, with MySQL up and running, oh, I forgot to point that out first. Make sure you have to start it before you go there through the command prompt as well. So with that up and running, the next button over is admin. If you click that, it'll open up a browser for us and open the PHP My Admin software. And if you're using a domain host, well, for AWS, I did make a video putting this same setup on an AWS server. It's a little different than what we did that first time. Setting up the exact same thing that's on XAMPP nowadays. PHP 7.2, MySQL 5.7, and PHP My Admin on the AWS server, which is also what you would see on most domain hosts. It's PHP My Admin is the most common one, and somewhere on your domain hosting site, there's a control panel, which is probably some software called cPanel. That is by far the most popular. But whatever control panel they use, if you go to the database section, you'll see a button that says admin. And when you click that, you'll probably going to look at PHP My Admin software, the software that I've pulled up on my screen right now. A lot of times, and like I said earlier, we don't have that create database command because the server admins will create a database for us. So if you don't have top level access, you won't have the nav bar down the side, but we have other navigation methods. So for XAMPP here, we have quick access to everything. So testDB, there's that database we just made. So I can click in there and load it up. If you don't have that access, I'll go in the other way as well. So I go back. We have breadcrumbs up at the top. Up at the top, you have those breadcrumb links. We can go back up to the top server and go to databases. And if you don't want to type create database or something, here's where you put that in the interface. Just give it a name and hit the button create. Or to get rid of it, select it from the list and hit drop. Be careful when the one you're doing, you're going to want to drop that a lot. While you're testing stuff, if there's any bad data, just drop the database and recreate it. That's the easiest way to deal with it. We'll see some stuff to make that, hopefully make that easier soon. But bad data from the debugging process is only going to confuse you. So make sure you delete bad data eventually, or delete bad data immediately, not eventually. Eventually needs to be right away so it doesn't confuse you in the next test run. So we can go in here and just click on our database. We can drop it from here, but we can also delete the data from inside. You can see, unlike the command prompt, we have buttons everywhere we can click on. So here's what makes up that database. We have two tables, a people table and a taste table, and then a bunch of buttons to click on. We can browse through it, the structure of it, and search for stuff in it. There's an insert button. So instead of typing up that insert query, we can hit the insert button and just use this nice little generic form, which is one of the things you probably want to put on your website, is a nice looking form to interact with your database. Because one here is just generic. It's supposed to fit any database. So you probably want to use one that's a little more structured for your database. But we can insert data there, or we could drop this table. Same thing on the other one. If we go into the table, click on people, here we can see our data. So over here's the data, and some more buttons over here. If we need to update stuff, really we have an edit button. So we can go right in there and just type in the boxes to edit the field. I'll use the breadcrumbs to get back to the previous one. We can delete some data. If you don't put the unique ID in, remember I said a moment ago, the unique ID, I just put that column in to assure we have a unique ID in every record, which is necessary to have full functionality from our relational database. So if you don't put a unique ID in, PHPMyAdmin won't give you these buttons on your table data. Not too big of a deal, but it's nice to have those buttons. And back up here at the top, we have, well, I'm going to use the breadcrumbs and just go back to the database and leave the table one and just be in that database. We have the table, or the tab SQL. If we click on that, here's where we type in our SQL commands, just like what we were seeing. So we could, well, I'll do that last one that we did. So select the people table, and notice right there, it has predictive text. So we can start typing, and when it shows up on the predictive text, just hit tab instead of typing everything. So from the people table, the name field, and from the taste table, the phase food field, from, and I got that from an F, people, join, paste. And notice I'm using the tab key mostly and selecting from that list. It's doing a really good job of predicting what I want. Where people.name is equal to taste.name, that foreign key that we connected them from. And I'll expand it a little bit further this time. Maybe, and age is less than 30. So anybody that's less than 30, we want to grab their name and favorite food from those tables. Hopefully all that looks familiar from SQL class, because our review, guys, going very, very quickly here. And we can type in the SQL commands and it's find the picture. If I enter a couple times, notice we get more line numbers. So we can type a bunch of them to do this one. And once you get it typed in, if there's errors, so like if I make a typo there, it usually underlines the errors. Oh, well, it's not underlining the error. Maybe Zoom is slowing it down. Normally, red line shows up like a spell check in most of our software, and a little red X will show up over on the line number. But for some reason, it's not highlighting that. Unless what I've changed it to was still a valid word. But once we type in the query, you come down here and hit the go button. And it should run that query. And if it works, you get a green, you'll see a green box, and there's the results. The names and favorite food of the people on our table under 30. So something you're probably going to want to do, I'll insert some more data. Insert into people, somebody else. Name, age, town, like we saw. The values, say Mary is 27 and lives in Gordon. And probably want her other data. Insert into taste, oops, name, and a food. The values, well, maybe Mary likes tacos. So that's going to add up a lot, right? And notice that, did you notice that after I ran that last query, it emptied that box out? So something that's definitely a good idea is while you're doing this, go ahead and copy that. I hit Control-C to copy it and paste it into a text file. Because, well, I'll do it from here. I hit run and go ahead and run that, but then it'd be gone from there. It's a good way to check it, make sure it works. But while you're typing it, it's a really good idea to type it over in a text file. So if I save this somewhere, put it on my delete folder. And we're going to see this more than once. From stretch out review, we'll see these points over and over again, but hopefully it hasn't been that long since you all had the database class. There's this Mary data.sql. So just like some of our other programming languages, it's a text file, but if we give it the .sql extension, .sql, the computer will know what to do with it. In particular, it'll change colors for us. Makes it a little easier to type like this for our code. So pretend that I like ran that query, made sure it worked, copied it over in the text file, something went wrong later, I had to delete a bunch of stuff, but I want to bring the data back in. So a few tabs over, we have this import tab. Yeah, that's fine. And come over to the import tab, and I can just choose that text file that I created with the insert queries in it. And all of our queries, not just insert queries, but those are the ones that can be a little tedious to type in. So it's good to have those that like create the tables and insert the data. Go ahead and set all that up in files so you can just recreate the database really, really easily. Then we can just upload that. Make sure the breadcrumbs are pointed at the database we want to work with. Select the file. Then when we hit go here, it'll run both those queries. Usually a lot quicker than that. I think Zoom is slowing it down quite a bit. Actually, it's probably Zoom and Google Chrome. Same thing that always slows down. So see, one row inserted. So if we navigate back to that table, well, either one, there's 5 rows now. That data's in there. We can run the same queries. So save your create and insert queries to a text file, or write them in a text file and then upload that file. That can make it a whole lot easier to just recreate the databases over and over and over again. So yeah, that'll give us a good start. So reviewing the MySQL stuff, and that gives us we got about an hour of lab time now. So y'all can play around with PHP MyAdmin, kind of click around, create some simple databases, and just practice databases like this. Create, some name, some basic data about people with more than one table, so that you can practice your queries. And those are the 4 big ones. So create tables, insert data into them, update that data. Let's see that one more time. Oh, and actually, notice up here at the top, whenever I click the button to ask for the table, it actually ran select all from people. So even in the background, when we click these buttons, they're running queries. So clicking buttons on the interface will give you another way to do that. So create tables, which you can also do from the database thing. There should be a new button here somewhere. Oh, there it is down at the bottom. We can give the table a name and hit create, and it'll create that for us. Then we have a nice little interface. It's a very generic interface because it has to work with anything. So there's a bunch of text boxes and drop-down menus is what they put together. They'll have the stuff. But we're going to need to do this stuff from PHP, which means we need to pass in the SQL commands. So you mostly want to click on the SQL tab and type those in, and make sure you copy them to a text file so you can recreate the database, or I guess over the next hour, just kind of get some practice at it. Or if you type them up in a text file, you'll come over to the import and upload the file of your create and insert data queries. Then come to the SQL tab and run your select and update queries, just to practice those. So maybe I'm gonna look at the data again and see what gets updated. So in the taste one, okay, so maybe this guy, David, suddenly developed an allergy to shellfish. He can't have lobster anymore, right? He was at Red Lobster, and somebody had to rush over with an EpiPen when he started swelling up. So that can't be his favorite food anymore. So we need to update our database. And notice the breadcrumbs went all the way to that table. So we've tried to start doing a select query on that table for it right off the bat. We don't want to update stuff. So the keyword update, and we want to update the taste table. Keyword set, and we're going to change the fave food column to be, what's an alternative? Steak, I guess. I don't need to put a lot of thought into that. But we only want to change that for that David fella in the database. So where name equals David. And that's our 4 queries. Create stuff, insert data, select the data, and sometimes update the data. Oh, not enter. I have to hit go. To enter in the command prompt. But it's kind of hard to work in a command prompt, right? I hit go, 1 row affected, and if we hit the breadcrumbs to go back to the taste table, you can see David's favorite foods now listed as steak. So those are the 4 queries you probably want to practice a lot and kind of click around this interface. You see there's a lot of stuff going on here. We'll pull up the structure of this table and edit all this stuff, change where our keys are, lots and lots of buttons. We need to pass this from PHP, which means we're going to pass in the actual language, the SQL commands. So you'll want to practice those a lot. But as far as like when things go wrong while you're practicing, and if you need to delete all the tables and start again, make sure you save it to a text file and then use the import button to quickly recreate it, or just kind of get some general practice. There's also an export button. We're going to talk about this more later. But we can export all the SQL queries. So if I hit go, I got a .SQL file and export different formats. XML, that's a markup language. So we save it with markup tags. CSV, that's comma separated variable. Those usually open by spreadsheets, with spreadsheets by default, but it keeps all the data separated and organized. A very quick way to do that. If I open that SQL one, it's probably in my downloads folder. Oh, we did it again. Windows is trying to update on me. It's trying to install a 13 gigabyte update, and I don't have 13 gigabytes free on my hard drive. So every day it runs almost all the space that is there out, and then cuts off at different points. But I keep running out of data like every day, and I'm not sure what to do about it because I use the ones that are essentially Chromebooks. I can't. Even when this was brand new, I couldn't handle a 13 gigabyte update on it. So I guess I'll just clear that every day when Windows tries to do it again. But you can see there's stuff there at the top. So here's the stuff to create the database. Recreate the database. So a create table query. And the insert into query, and they just did it all as one. Passed them all in as one instead of separate ones. Then they came back and added the primary keys and stuff. But all the queries necessary to recreate that database. I guess that was only the table. We go to the breadcrumbs. Take the breadcrumbs up to the database, and I'll export this one. So instead of just I had the table selected. You can tell where you're at, what's selected based off the breadcrumbs up at the top. There we go. So now if I open this one, SDB.SQL, edit that with Notepad++. Here we go. Here's the thing to create all the whole database. So, well, this one just says what database we're using. It didn't actually create it, but then create the people table, put all the people data in, create the taste data, put all the data in. So whenever you do your homework, if you don't type it up in a text file and you just do your database for the homework assignment all in the SQL commands, make sure you export it and send that to me so that I can recreate your database whenever I'm grading it. But you'll probably have that around anyway. That way, if things go wrong and you need to delete your database and start over for your testing and reviewing stuff, you'll have it on a text file. Or the best idea is probably write it in a text file along the way, and that way you have that on hand, stored with the files for your website, and it's just like another resource that your website needs is the SQL queries to initialize the database that it's going to take to run it. Does anybody have any questions about that? We will see that more. So there's more review coming. We'll see this stuff over and over and over again. I just kind of want to do a quick overview review of the SQL we need. And this is probably the most popular interface for working with MySQL stuff. So you'll see this one all over the place. And it does a lot. It has, with mouse clicks, we have full control of the database. So there are a lot of functions here, and as we click on different buttons, the buttons we have access to change. So you'll probably want to click around a little while, get used to PHPMyAdmin and review SQL a little. So that's what I was thinking for lab day today. Got about 15 minutes left to just kind of click around on that. Anybody have any questions? Okay, and remember that I did specifically split the video up so the MySQL stuff started at the beginning of the video. So as soon as the recording comes up, which will be here in a few minutes, or as soon as that comes up, I will get it on the IB Learn page, and video 3 is where the MySQL stuff starts. Otherwise, I'll see you all on Thursday. Everybody have a great afternoon.